In today's lecture, we will see all about alkane. We will see all about alkane. A L K A N. We will see all about alkane. What is mean by alkane? Alkane is a saturated organic compound. Alkane is a saturated compound. Saturated alkane is a saturated compound. Means saturated means alkanes contain single bond. For example, CH3 single bond CH3. This is alkane. Between these two carbons, this is single bond. Means alkanes are saturated carbon containing saturated organic compound. Organic compound means compounds which contains carbon. Alkane. Then all of you know carbon can form how many bonds? Carbon can form 4 bonds. Means valency of carbon is 4. Valency of carbon is 4. For example, we take the example of methane. CH4. Carbon is at center and there's 4 hydrogens. Means carbon having valency 4 means carbon can form 4 bonds. Next, we will see preparation methods of alkane. Preparation methods of alkane. C. First method is when hydrogenation of alkene. For example, this is alkene, this is ethene, and in this ethene, when this ethene is react with H2 hydrogen in presence of Raney nickel, and there is heating. When ethene is react with hydrogen in presence of Raney nickel and there is heating, then there is formation of ethane, means formation of alkane. What happen? These two hydrogens are one hydrogen attaches this carbon and second hydrogen is attaches to this carbon, and carbon double bond converted into carbon single bond, and there is addition of hydrogen on adjacent carbon atoms and there is formation of ethane. This is simple. Next, this is propene. When react with hydrogen in presence of Raney nickel and there is heating, then formation of propane. Simple. On these two double bonded carbon atoms, there is addition of hydrogen, and carbon double bond is converted into carbon single bond. Next, in case of alkyne. In case of alkyne, there is requirement of 4 hydrogens. There is requirement of 4 hydrogens and addition of 4 hydrogen on adjacent carbon atoms, double bonded carbon atoms, and triple bond is converted into single bond and formation of ethane. This is an example of propane. When there is addition of 4 hydrogens in presence of nickel and there is heating, then formation of propane in the same way as explained above. Next method, by from Grignard reagent. Preparation of alkane from Grignard reagent. When this Grignard reagent react with water, means there is, when hydrolysis of this Grignard reagent, then formation of alkane. See the example. This is ethyl magnesium bromide. When hydrolysis of ethyl magnesium bromide takes place, the bond between this carbon and magnesium breaks because this is in this way, CH3 CH2 Mg and Br. This magnesium acquires positive charge. This carbon acquires negative charge. And there is hydrolysis, means water molecule, HOH. H carry positive charge, OH carry negative charge. This negative charge abstracts this hydrogen, and formation of alkane. Formation of alkane means formation of ethane. This is product, CH3 CH2 and this hydrogen H, means this is ethane. In a case of secondary butyl magnesium bromide, this is also Grignard reagent. This carbon acquires negative charge and magnesium acquires positive charge. In the same way, hydrolysis takes place. This hydrolysis of second butyl magnesium bromide takes place, and formation of this bond carbon and magnesium, the bond between carbon and magnesium breaks, and hydrogen is attached to this carbon atom, and formation of N-butane. Next method of preparation methods of alkane is decarboxylation of fatty acids. Decarboxylation means removal of CO2. By heating a mixture of sodium or potassium salt of fatty acid. This is sodium salt of acid and soda lime. This is soda lime, calcium carbonate, CaCO3. We get an alkane containing one carbon atom less than fatty acid. See example. Decarboxylation. Suppose this is sodium acetate, CH3 C double bond O, CH3 C double bond O minus and Na, O minus and Na plus, O minus and Na plus. This is sodium acetate, and means there is decarboxylation takes place. Decarboxylation means this negative charge is shifts between this carbon and oxygen. That's why this bond between carbon and carbon is acquired by this carbon, and remole of CO2, remole of CO2. This is called a decarboxylation, and formation of alkane. In case this sodium formate, there is formation of methane, and in case of sodium propionate, formation of ethane, CH3 minus formation next method is from alkyl halides. This is nascent hydrogen. What is mean by nascent hydrogen? This nascent hydrogen is formed when there is reaction between zinc copper couple and alcohol. Zinc copper couple and ethyl alcohol. When there is reaction between zinc copper couple and alcohol, ethyl alcohol, and there is formation of nascent hydrogen, and when this nascent hydrogen is react with methyl iodide in presence of zinc copper couple and alcohol, there is heating, means methyl iodide when heated with zinc copper couple and alcohol, then there is formation of methane. How this takes place? The bond between carbon and iodine break, and one nascent hydrogen attaches to this carbon atom and another hydrogen atom and this iodine, formation of hydroiodic acid, hydrogen iodide, hydroiodic acid formation means hydrogen iodide takes place, formation of hydrogen iodide takes place. Next example, ethyl bromide. This is ethyl bromide. The bond between carbon and bromine break, and to this carbon atom one nascent hydrogen attaches, then formation of ethane and remaining one hydrogen and this bromine, formation of hydrogen bromide. This is simple method for formation of alkene. Next method is by Wurtz synthesis. See explanation. Alkyl halides on heating with sodium metal in presence of dry ether as a solvent give higher alkanes. Higher alkanes means alkanes having carbon atoms higher than the reactant, higher than the parent. In this reaction, two molecules of alkyl halide combine to produce higher alkanes containing even number of carbon atoms. The reaction is called Wurtz synthesis. There is high possibility of this question coming in the exam. Always there is question on this Wurtz synthesis in the exam. That's why this is very important. See, when there is two molecules of methyl iodide, this is one molecule and this is second molecule, methyl iodide and methyl iodide. When these two molecules of methyl iodide are combined in presence of sodium metal, and in this reaction dry ether is act as a solvent, means in this reaction, and then there is formation of ethane, these two Na and these two iodine, formation of 2 NaI, and this CH3 group and this CH3 group are combined and formation of ethane. Next, see the next example, ethyl bromide. When two molecules of ethyl bromide are heated in presence of sodium metal and in presence of dry ether as a solvent, then there is formation of, then these two groups are combined and formation of N-butane and formation of byproduct sodium bromide, this two sodium and this two bromine, therefore there is formation of 2 NaBr. Next, reactions of alkanes. First reaction is halogenation. When the under the influence of ultraviolet light or at 200 or 400 degrees Celsius, chlorine or bromine react with alkanes by replacing the hydrogens. The reaction containing as long as hydrogen atoms are available for replacement, giving rise the mixture of products. When this methane is under the influence of chlorine, when this methane is react with chlorine in presence of ultraviolet light, then there is formation of methyl chloride, means one hydrogen atom of this methane is replaced by chlorine and formation of methyl chloride. Then again this methyl chloride is react with chlorine in presence of ultraviolet light, and second hydrogen atom of this alkyl halide methyl chloride is replaced by hydrogen atom. Next hydrogen atom is replaced by another chlorine and formation of methylene dichloride. This reaction takes place until all hydrogen atoms in this alkane are in this starting compound reactant are replaced by chlorine, and at the end there is formation of carbon tetrachloride. This reaction is not that useful as it is very difficult to separate the different products, means there is formation of mixture of products, and every individual product there is difficult to separate every individual single product, and yield of the individual halogen derivative is very, that's why, poor. Next, see, for example, this is propane. When this propane is heated with chlorine, then there is possibility of formation of two products, one chloropropane and two chloropropane. See, the proportion in which the mono halo derivative formed depends on the type of hydrogen atom replaced. This was shown by Markovnikov that reactivity of hydrogen atom towards halogenation is in the order tertiary, then secondary, and then primary. Means tertiary hydrogen atom is more reactive towards this chlorine, then secondary hydrogen atom is more reactive with respect to primary hydrogen atom to this chlorination reaction. See in this example, this is propane and this is propane, and the hydrogen atom on this carbon atom, this carbon atom is attached to another one carbon atom. That's why this is primary carbon atom. This is primary carbon atom, and hydrogens present on this carbon atom are primary hydrogens. And one chlorine hydrogen atom on this attached to this primary carbon is one hydrogen atom is replaced by chlorine. That's why this is 1-chloropropane. But this carbon atom, see this carbon atom, second carbon atom is attached to another 2 carbon atoms. That's why this is carbon atom is secondary carbon atom, and hydrogen atoms present on this carbon atom are secondary hydrogens. That's why secondary hydrogen atom is replaced by chlorine, and this is a major product. See in this example, N-butane is react with chlorine, then there is formation of 1-chloropropane and 2-chloropropane. Reactivity order, see this reactivity order. In this first product, hydrogen atom on this carbon atom is attached to another single carbon atom. That's why this carbon atom is primary carbon atom, and this hydrogen atom is primary hydrogen. That's why this product is formed 28%, and this hydrogen attached to this carbon atom is secondary carbon atom, because this carbon atom attached to another 2 carbon atoms. That's why this is secondary carbon atom, and hydrogen on secondary carbon atom is replaced by chlorine, and there is formation of 2-chloropropane, and this is a major product. This product is formed as this product 72% formed. See another example. See this example. See this example. Isobutane. See isobutane CH3 carbon, hydrogen is attached to this carbon, and this is CH3, and this is CH3, and this is CH3 molecule. And when these isobutenes react with bromine, Br2, this carbon atom is primary carbon atom, this carbon atom is primary carbon atom, this carbon atom is primary carbon. That's why hydrogens on this carbon atoms are primary carbon hydrogens. This center carbon atom is tertiary carbon atom, because this carbon atom is attached to another three carbon atoms. That's why this is tertiary carbon atom, and this is tertiary hydrogen. That's why this bromine is, this hydrogen atom is replaced by bromine, and there is formation of 2-bromo 2-methyl propane. 2-bromo 2-methyl propane. This hydrogen atom is replaced by bromine. Numbering, IUPAC name of this compound is, suppose 2-bromo 2-methyl propane, 3 carbon atoms. We will see remaining part in the next lecture.